Welcome back. Problem 2, Statistics 4.2. Heights in centimeters and weights in kilograms of 7 supermodels are given below. Find the regression equation letting the first variable be independent. So height is x and weight is y. Alright. So notice weight depends on height. So height is the explanatory variable, weight is the response variable. So we need to be able to find regression equation, which is y hat a plus bx, and use this regression equation to find the weight of a predicted weight of a supermodel who is 171 centimeters tall. So basically, you want to find the regression equation. If you recall, regression equation looks like this. Y hat is a plus bx, where b involves this formula. B requires an n summation xy, summation x, summation y, summation x squared, and summation x, the whole power 2. So that's for B. Okay. For A, you need y bar minus b x bar. X bar and y bar being the mean. So we need to calculate x bar and y bar also. So to begin with, we need n. How many supermodels are there in our study? 7. 1, 2, 3, 4, 5, 6, 7. So n is 7. All right. What's the next thing? I want to find summation x. That is, let me add all the x values. Summation x. 174 plus 174 plus 172 plus 176 plus 168 plus 178 plus 176. 1218, that is adding all the x's, summation x, 1218. Okay, now let me square each one because I also need summation x squared. So while I'm here, I may as well square each guy. Okay, 211996. 211996. Now, after summation x squared, I also need summation y. By the way, I also need summation xy. So while I'm here, I may as well multiply x to y and then take care of that while we are here anyway. So these are the x values right now. I'm going to multiply each of the x values to its corresponding y value. All right. So 174 times 54. 174 times 55. 172 times 52. 176 times 56. 168 times 50. 178 times 58. 176 times 55. So that is summation x times y. All right, summation x times y, 661070. Now let's look for summation y. In other words, I don't need the x's, only add the y's. Make sure we have it correct. As you can see, I almost always try the problems first on my own and then tape it for you. So if I add all the y's, I should get 380. Very good. Now that you have all of this, how do you find x bar? X bar is add all the x, divide by the total number of x's. So it is going to be 1218 divided by 7, 174. Good. How do I get y bar? I add all the y's and divide by the number of y's. So that's 7. 380 over 7. 54.28571429. Fantastic. So we came this far. Now finally we are ready to find b. So what is b? b is a numerator over a denominator. A numerator divided by a denominator. Let's keep parentheses handy. Upstairs, n times summation xy. n is 7 times summation xy, 66170, minus summation x, summation y, 1218 times 380 over, oh, I'm sorry, I'm looking at this one, okay, not the one above, this one. Numerator is the same, no harm done. Denominator, n times summation x squared. n is 7 times summation x squared, 211996. 211996. Fantastic. Minus, take all the x's, add them up, 1218, and then square it. So this is what we get for b. The thing is, whatever b you get, first check whether it's correct. Only then you proceed. So that's the b slot. So mind you, what did we get? B. So that's the b slot. Submit. Okay, it's correct. Fantastic. Once you have b, you can find a. A is y bar minus bx bar. So I may as well avoid approximations. So I will simply say y bar, what was it, the formula? Y bar minus bx bar. Okay. So notice how y bar looks like. It's an approximate number. And if you recall, what was y bar? Y bar was y over summation y over 7. So A will be y bar 380 over 7 minus B times x bar. B, we just had B. B times x bar. X bar is 174. Submit. All right. So it's happy with A and B. Now the last case is you want to plug in 171 here. So I will take this guy, write as it is, plus this guy, copy and paste as it is, times is a star in WebWork, x is 171. That's correct. Next problem. A researcher observes that on average, number of divorces in cities with major league baseball teams is larger than in cities without Major League Baseball teams. So cities with Major League Baseball teams have more divorces. The most plausible explanation for this is the association is due to the presence of a lurking variable. You see, Major League teams tend to be in large cities. Large cities have more people. Therefore, you will have more divorces. Okay, it is also it is not necessarily coincidental, because a researcher has observed on an average. Okay, the presence of a Major League Baseball team causes divorces. That's not at all true. High number of divorces is responsible for presence of, that also does not seem right. It does seem that the case that Major League Baseball teams exist in large cities. Large cities have more people. If you have more people, you will definitely find more number of divorces. It's simply that's how. Now, when possible, the best way to establish an observed association is the result of a cause and effect relation. Well, the best way to establish is an experiment. Correlation coefficient, etc., is simply by observing, and you calculate your coefficients and so on. But to establish a cause and effect, well, the best possible way is to have a well designed experiment. The owner of a chain of supermarkets notices that there is a positive correlation between sales of beer and sales of ice cream. Seasons when sales of beer were above average, sales of ice cream also tended to be above average. Likewise, during seasons when sales of beer were below average, sales of ice cream also tended to be below average. Which of these? Well, the sale of beer and ice cream may both be affected by another variable, for example, temperature, of course. In summers, we tend to have more ice cream and maybe more beer too, right? Because chilled beer and so on and so forth. Well, for a significant proportion of customers, drinking beer causes a desire for ice cream, or eating ice cream causes a thirst for beer. That doesn't seem to be true, right? That doesn't seem to be logical. Sales records must be error. There should be no association. Well, that's assuming the worst. We are assuming this information is valid. A scatter plot of monthly ice cream sales versus monthly beer sales would show that a straight line describes the pattern. It would be horizontal line. Why would it be horizontal line? That has no meaning, okay? None of the above. I'm suspecting this outside temperature could impact sales of beer as well as sales of ice cream. All right, so they are all correct. So this completes Stat4 2. Next videos will cover chapter 5. Until then, bye.